with the answers. Okay, so ready to go with the answers to the assessment that we did the other day. So let's start from the top. Number one. Now, another nice standard question. What do we mean by an algorithm? So what is meant by the word algorithm? So algorithm, remember, two things you have to describe. Number one, it's a set of instructions or steps. So set of instructions or steps, that's 1 mark. Leading to a goal. So leading to an end. Okay, a set of instructions leading to a goal. Hold on a second. I think I'm going to just grab a black pen. The green's not very good, is it? Hold on a second. I've got a green pen somewhere. Black pen, rather. Just getting the pot of pens, and there must be a black. Yeah, here's a black pen. Right, black, much better. Let's carry on. Okay, so black leading to a goal. Number two, breaking down a problem into smaller parts to make it easier to solve is, well, abstraction is taking away unnecessary detail. Delineation doesn't exist, that's just made up. Decomposition. Decomposition is what you're looking for, breaking down something. Remember, something that decomposes, breaks down. So I'm going to put decomposition as my answer there. Activation, no idea what that means. That's just made up as well. Number three, give 2 reasons why a program is often broken down into separate functions. 2 marks, 1 for each reason. So let's give some reasons. So we could talk about it's being easier to solve small problems. So you can solve small problems in a much easier way. And that means that you can solve them straight away without, and then put the answers together. You can talk about the fact that it's easier to find mistakes. So if there's a mistake anywhere in the program, and you know which part of the program it's in, you know where to find the mistakes and how to fix them. You can talk about the fact that you can give it to different people. You can give it to different people. So each part can be given to a different person. That person can solve one part, another person can solve another part, and so on. You could talk about the fact that the same part can be used over and over again. So if you've got a piece of code that does a particular job, maybe it works at an average or something like that, then if you need the average worked out at one point in your program, you use that piece of code there. But then, of course, later on, when you want to use the averaging part again, you can use that part again. So you don't have to keep rewriting, don't have to keep reinventing the wheel. So any 2 of those 4 will be fine for you. Number 4, programmer writes a program for a teacher. The Python listing has 6 errors in it. Well, let's have a look down here. So name equals input, please enter name. So we've got the variable equals to assign, input, speech marks at both ends, brackets at both ends. Nothing wrong with that at all. Mark equals int. Yeah, int for a number. Remember, mark is going to be a number. So we're going to assign a number. So we want to turn it into an integer. Bracket, input, bracket, speech marks there for please enter a mark. But look, only 1 bracket at the end. 2 opening brackets. So we're missing a second bracket there. Let's look on first and down. Total equals input, speech marks. What is the test out of? Speech marks, closing brackets. No problem there. But total is a number. We're going to want to divide by that in a minute. So we need to have in there, we need to have int and a bracket there and a bracket on the end. So total equals int input. What is the test out of? Perc, I guess that's short for percent, equals mark divided by tote times 100. Tote, what's that? Never heard of that before. We called it total before. That needs to be changed to total. It's a common error that people bring in variables with different names, assuming that they're the same thing. But if you call it total there, you must call it total there. If perc is greater than or equal to 50, fair enough, but you're missing a colon. Put the colon in. Print pass. We're missing speech marks, aren't we? Speech marks around pass. Otherwise, it thinks there's a variable called pass. There is no variable called pass. We need some speech marks there around pass. Else, colon, nothing wrong with that at all. Print, need to repeat. So if your mark, the percentage is not more than or equal to 50, then you're going to print pass. Otherwise, you're going to print need to repeat. Nothing wrong with that. Print, speech marks, brackets, need to repeat, but you need to indent it. After else, after any line with a colon on it, you must indent. So your 6 errors. This line here needs a second bracket. This line number 3 needs an int. Number 4, tote should be total. Number 5 needs a colon. Number 6 needs speech marks. And number 8 needs to be indented. Okay, moving on. That's dealt with number 4. Number 5. Line up a little bit. That's better. That's a bit more lined up, isn't it? Okay, so number 5. The bit pattern shown below is stored in 1 byte of computer memory. A, explain why computers store data in binary. 2 marks, so you need to make 2 points. So 5A, 2 points about binary. So number 1, you need to say that computers use switches, and if you're feeling really smart, you'll put transistors. The transistors are the individual electronic devices that act as a switch to store data. So that's 1 point. And then 1 is on, 0 is off. 1 mark there, 1 mark there. So you need to make the point that we use binary, not just to make your life a misery, but because computers use digital computers, modern digital computers, use switches inside them, little tiny transistors that store the data. And when they're switched on, they're a 1. When they're switched off, they're a 0. Convert the binary number into a decimal number. Okay, let's go through that. So on here, I might as well mark it on here, save time. So 1, 2, 4, 8, 16, 32, 64, 128. So we've got a 64, an 8, a 2, and a 1. So we just add up 64 plus 8 plus 2 plus 1. 64 plus 8 is 72, plus 2 is 74, plus 1. So in decimal, that's 75, 1 mark. Convert the binary number into a hexadecimal number. Now remember, we can do this very easy by splitting our binary number into 2 nibbles. So this one here is worth 1, 2, 4, 8. Remember, a nibble is 4 bytes. So that's easy. That's a 4. And this one here, 1, 2, 4, 8. 8 plus 2 plus 1, that's 11. Now we can't write 11 down, it needs to be a single digit. Now remember, in hexadecimal, A is 10, B is 11, C is 12, and so on. So 11 is B. So you can have 1 mark for doing the split and the conversion into the numbers, another mark for turning 11 into B, that's 2 marks for B. And if you want to, you can check back to make sure you got it correct, because 4 lots of 16 is 64 plus 11, 75. There you are, and we know it's 75. Part D. Wallace is describing the use of hexadecimal. He says hexadecimal is used because it takes up less space in the computer memory. Explain why he is wrong. Well, why is he wrong? Well, we need to start off by saying that computers only store binary numbers. Well, that'll get you a mark. So the hexadecimal has to be converted to binary to be stored. There's your second mark. Basically, it's the wrong answer because only binary numbers can be stored in computers. And we know that. E. The bit pattern above can be understood as a single ASCII character. If 01000001 encodes the letter A, which letter is encoded above? Show you're working. Well, let's look at this. So 000001 equals A. So, and that, if you look at it, that's a 64 and a 1. So that is 65. So A is 65. So the one we want, so 75 is 10 more. So this is the 11th letter in the alphabet. What's the 11th letter in the alphabet? Well, A, B, C, D, E, F, that's 6. G, H, that's 8. I, J, that's 10. K is the 11th letter. And that's how we do that. Right, last question. Unicode is now used much more than ASCII. Give one reason why Unicode is more appropriate as a standard for computer text. And this is where you need to talk about the fact that ASCII only encodes, if you were to write ASCII only encodes the Western alphabet, you wouldn't be far wrong. If you were to write, there are lots of different character sets, e.g. Arabic, Japanese, and these are not encoded. Whoops, stay on the page. These are not encoded by ASCII. That'll do. Any point you've made about the fact that there are lots and lots of different characters in the world, that ASCII doesn't encode those different characters, that'll get you the mark. Okay, moving on. Let's go on to our next page. So let's write actually on the sheet here now, make it be much quicker. So we've got the programming languages allow for the use of a number of data types. These include string, char, integer, float, boolean, date. For each of the variable names listed below, state which data type they should be assigned. Name of student, clearly string. Date of birth, date. Bit obvious that one, isn't it? Allowed discount. Now you could get away here with boolean. Oh, that noise in the background means my wife and father-in-law are about to arrive, so I might have to warn them off. Hold on a second. So allowed discount may be yes or no. So we'll say that's boolean. So I would let you have car if basically if you're going to write Y or N maybe for those. You could just about get away with saying it's string. Just about. But the best answer is boolean. Price of item includes pence. That must be float because it has to have a decimal part to it. Right. In a game, the value for highest score is stored as a constant. When the game is played, highest score is set to 150. So the value for highest score is stored as a constant. We talked about constants the other day. What is the difference between a variable and a constant? 2 marks. So you're going to want to have two things here. So you need to say something like variable can be changed in the program. Whereas a constant always stays the same. 1 second, I'll just tell people what's happening. I'm just recording over here, so if you can bear with me, that'd be brilliant. Thank you. So we've got two things here. So the variable can be changed in the program, but the constant always stays the same. 2 marks. Now your flowchart, nice and easy, we're told. So we've got to try and think what's going on here. So Quick Coaches supply coach services across the UK. A return ticket costs 1.5 times as much as a single ticket. Travelling first class costs £20 more than a standard class ticket. The flow chart shows the algorithm for calculating a person's ticket price. What should be written in the box labelled A, B, C, and D? Right, 6 marks for this. A, it's a start box. That'll get you 1. Right, enter destination, find ticket costs. So that's the classic ticket cost for that destination. Now enter the type and the class. So we want to know the type, whether it's a standard or return, or class, is it first or second class? So at this point, at B, we're going to need to be asking the question, is it a return? So for this one, I would put something like type equals return, question mark, or just return. And you can have 2 marks for that one. So that's 2. Right, first down here. So if the answer to the question return is yes, then we set the ticket cost to be 1.5 times. Otherwise, no, we just carry straight on. Is it first class? Is the class first class? Then if the answer to that is yes, what do we do with it? We set the ticket cost to be equal to ticket cost plus 20. We add 20 onto the ticket cost. You can have 2 for that. And then last of all, what do we do here? We output ticket cost. And you can have 1 mark for that. Right, nearly there on the last lap. And we're on to our pseudocode, everybody's favorite. Right, let's have a look at what pseudocode does for us here. So, look at the pseudocode below. This is an algorithm used by a train company. Int converts a number into an integer by removing the decimal part of the number. Okay. So we're going to set max to be 4. Max is a constant. That's why it's in capitals. We're going to set per carriage to 50. So I think I'm guessing at the moment that this is the a number of people that can fit in a carriage. Right, we ask for the number of passengers, the user input. The number of carriages is the number of passengers divided by the per carriage. We int that gets rid of the decimal part, and we add 1. So for example, if there were 110 passengers, 110 divided by 50 would come out at 2.2. Int that's 2, add 1 makes 3. So we need 3 carriages to carry 110 passengers. We output the carriages. So easy questions after what I've just said. Now, number 9. What name one constant? Well, either max or per carriage. Either of those are constants, and the clue is they're in capital letters. Constants are pretty generally always put in capital letters. Part B. If the user enters number 225 when prompted, what number will be output? Well, let's think about that. They're asked, they type in 225. We do 225 divided by 50. 225 divided by 50 is 4.5. Int that makes it 4. Add 1, the answer is 5. What is the purpose of this algorithm? Well, the purpose of the algorithm is to show how many carriages you need. How many carriages are needed on a train journey? And last of all, the fun part, write pseudocode to add to this algorithm. This will check the value of carriages against the number stored in max. If the number is too high, an appropriate message is output. Right, so we need to check to see if the number of carriages is too high. Now we've got max here to tell us what's too high, and we know that carriages is the number of carriages. So if carriages is more than max, so you can have 1 mark for saying if, you get 1 mark for saying the check, so that's 2 marks. So if carriages is more than max, you can just about get away with it if carriages is more than 4. I'll let you off on that one, but really you should be using max. What are we going to do? We're going to output. You can get away with print there. Too many people. What's it say? Does it say what you should say? An appropriate message. Too many people for this train. And then we're going to put end if. So 1 mark for your output, 1 mark for your end if. 1 mark for the if, 1 mark for the check, 1 mark for the output, 1 mark for the end if. Okay, good. Right, and that's all.